So we calculated X bar chart. Yes, I know it was very exciting. You guys loved it. So now let's go to the R chart, which is also very exciting. Whoops, not this one. This is how you calculate the R chart. Okay, so R chart is the range. Remember, R is the range. And we have the same easy peasy table here to take a look at. Okay, and the only thing that you need to know is what is n. Do you guys remember what n is? I explained it in the last video. What you have here in their PowerPoints, n is the number of observations in each sample, right? We go back, oops, not too much. We have 1, 2, 3, 4, 5 observations in each sample, so n equals 5. And then I have to look at the nasty values of D4 and D3. So n equals 5, D3 0, D4 211. And we know what R is. R bar is the mean of the range, which is 0.220. Okay? The R bar, right? So we have R bar, we have D4, D3. We can do it very easy, right? So multiply here. My upper control limit is 0.465, too many decimals. And my lower control limit is going to be 0 because D3 was actually 0. Okay? And then, if you plot it, you have the upper, you have the lower, 0. You plot all the R's, right? And now it's going to, what I'm plotting here are those numbers, right? 0.11, blah, 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 so forth, so on. Here? No. Here. Okay. So I plotted all the R's, right? And the question here, sample number, and the question is my process under control, yes or no? This time, I want you guys to scream really, really loud. No, it's not, right? Hopefully you saw the dots that I highlighted very, very much here in the red circle. And that dot there, that sample is telling me that the process is not under control. So something happened on sample number 8 that impacted my process and made the process produce very far away from the mean. So there's a special cause variation happening there, and because of special cause variation happening there, my process is not under control, right? And then next one, going back, so I know that's sample number 8, right? So going back here, I go to sample number 8, and I take a look at the values. 10.74, 10.78, 10.11, 10.74, 10.75, right? Which one is the outlier, or how many outliers I have? I have one out. Oh, I forgot to ask you guys to screen, but I have one outlier here, which is observation number 3. You can see that this value is a lot lower than all the others. So what's happened? The average have an impact, but the range has a big impact, right? Because the difference between the 10.78 and 10.11 was about 0.67. And because it was 0.67, that's why this dot was so far away from all the others. If I look at both simultaneously, it's a nice word, I can see that it went through the means, right? It reduced the mean, but it was still, within the limits. But when we came to range, that was way outside the limits, right? So here could be because all of the data points could be a little bit lower, and that's okay. But when one of them was very, very different, the range will point it out, okay? And here is just highlighting number 4, because number 4 was very close to the mean and very close to the average range, right? So very, the one that's most likely to have, okay? So hopefully those are all the question doubts that you guys had about the R charts. We're going to play with them a lot in class, do different and cool R charts. Just to finalize here, there's another way to calculate for X bar, the upper and lower control limits, which is just taking in consideration the 3 plus or minus, X double bar plus or minus 3 standard deviations. But that's usually done when we know the standard deviation of the population, which is not very easy to know. So usually you're going to use that table, but when the problem tells you that you should use that the standard deviation, then you can use it. Okay, and that's the formula even easier than the other one. X double bar plus or minus 3 times the standard deviation. Okay, if not mistaken, one homework actually is about using that. Okay.